We are AcoustaMed, and we will be presenting to you the future of medicine through a revolutionary new way to perform mRNA research that will drastically decrease the time taken to develop vaccines, perform cancer research, and develop cell therapy techniques, and so much more. We're all familiar with the pain and boredom that came through the quarantine that resulted from the COVID-19 pandemic. We stayed away from our loved ones. We stayed away from businesses, and we were in isolation for over a year as we awaited a vaccine or some kind of solution. This solution came through the novel mRNA vaccine that was introduced in 2021. The CDC says that there is a 45 to 57% chance that another pandemic will happen in the next 25 years. So the need to develop these vaccines faster and more efficiently is at an all-time high. A recent New Scientist article describes the utilization of the mRNA as the future of medicine. The way this technology works is the cell is taken out of the body and the mRNA is placed into the cell. This cell is then put back into the body where the mRNA has special instructions for changing the purpose that the cell carries out within our bodies. This purpose could be special instructions to tell a white blood cell to attack the COVID virus, or maybe even attack cancerous cell. Possibilities are endless with genetic modification using mRNA. Currently, the means of putting mRNA within the cell is incredibly labor-intensive and slow, with lab technicians spending hours of their time learning and performing this long and tedious task. Processes can take upwards of 48 hours or 2 days for each individual test. However, thanks to AcoustaMed's novel microchannel paired with acoustics, we can perform the same task in less than an hour. That's a 99% time reduction. This 99% time reduction will increase the rate at which vaccine development and genetic research is done. Time reduction and ease of use of our solutions show promise to genetic engineering implementation into clinical benefits. At AcoustaMed, we have developed an all-encompassing autonomous device to speed up the process at which genetic engineering is done. By partnering with Dr. Ding's mechanical engineering lab at University of Colorado Boulder, we have been able to use our mechanical engineering background to produce a mechanical solution to a field that's dominated by biochemical solutions. The genetic engineering device is easy to use and includes a touchscreen, durable enclosure, disposable cartridge, and adaptability to any United States standard wall outlet. The secret to the time reduction lies in just one step of the lengthy process of vaccine development. Similarly, the Polaroid camera was able to achieve the same outcome as film development, just with a decreased time in one step in the process. In the same way, our device will achieve the same solution as current methods, just in a dramatically reduced period of time. How it works is easy. The lab technician inserts the cells and their mRNA solution into the cartridge, and the cartridge will be put into the device. They will then simply press run and sit back and watch as the process takes place. They will retrieve the finished cells and observe their observations. The current market is valued at $1.04 billion, which is expected to grow at 7.73% per year. However, due to the increasing need for production, this rate could increase rapidly in the coming years. Other companies that play a role in this market include Thermo Fisher, which has produced the neon transfection device, and other devices that use harmful reagents to perform the same task. Our genetic engineering device will be easier to use through the elimination of cluttering lab supplies and expensive testing equipment. The semi-autonomous nature of our device will allow the lab technician to simply watch the process take place and eliminate the human error. The genetic engineering device will also be much faster as we have incorporated this 99% time reduction that was mentioned earlier. The applications of the device are vast and include, but are not limited to, mRNA vaccine development, cancer research, and cell therapy. The rate at which research is done in all three of these fields will be positively impacted because of the decreased time in the process. By looking at 120 different biochemistry labs across the country, we predict that we can acquire 5% of the market every year for the next 5 years. This results in roughly 6 units being sold every year and AcoustaMed becoming profitable by year 4. Major expenses in 1 year includes the development of injection molds to speed up manufacturing time and decrease future manufacturing costs. We base these predictions on a competitive pricing model by selling each device at $4,000 with a recurring purchase of 4 cartridges per month at $300. which allows for us to come in significantly lower than our competitors. Therefore, we believe that this will be appealing to labs across the country. Our team, composed of mechanical engineers, has overcome gaps in knowledge in biochemistry to provide a device that will revolutionize the field of genetic research. We are up to the task of ensuring that this device is state-of-the-art and can keep up with the growing need of this market. We are supported through an outstanding group of engineers, with Kevin and Dr. Dean being leading experts in the field of mechanical genetic engineering research. In addition to them, Param and Walter have many combined years of experience mentoring startup companies and could continue to advise us through the future of our company. Thank you.